So sorry. Sorry. Hello, hello, hello. Hi guys. Am I audible now? I'm so very sorry. I forgot to switch on this mic we have na. I forgot to switch it on. I'm so sorry. My apologies for this surprise. Sir, you see happy today. I'm always happy. Is it coming now? Good morning, boys and girls. Very sorry, my apologies here. है ना? I was just trying to test how many of you are attentive in the class. How many of you can understand my feelings without hearing me? Okay, good morning everyone. Good morning. I am good. Dragon says 2 minutes wasted. The time which you enjoy wasting is not wasted, Dragon. Don't you know that? The time which you enjoy wasting is not wasted. Okay, good morning boys and girls, everyone. Shall we start with the class? Are you all ready? So I think we were discussing about good morning. So we were discussing about relative atomic mass, if you remember. So the last concept which some of you had asked was, sir, what is percentage abundance? What is percentage abundance? Okay. So see, percentage abundance is something which tells us about the ratio in which the different isotopes would occur. So for example, let's consider that example once again. So chlorine, as I told you, everyone pay attention. So chlorine, as I told you, has two isotopes. One is chlorine 35 and the other is chlorine 37. These are the two ways, these are the two isotopes of chlorine, right? So I told you that if I ask you atomic mass of chlorine and suppose you reply as 35. So if you reply as 35, then 37 would feel bad. And if you reply as 37, then 35 would be feel bad. So giving 35 will make insult 37 and giving 37 will insult 35. Understood everybody? So in this case, what we do is we have to calculate their average according to their percentage abundance. Now, percentage abundance is something which is an experimental data. It will be given to you in the problem. You cannot find that out on paper. Okay, everybody? So what is percentage abundance? Percentage abundance is the ratio in which percentage abundance is something which will be given to you in the problem. It is experimental data. Okay, so percentage abundance is simply the ratio in which the atoms, better word would be to use isotopes. The ratio in which isotopes occur simply means found. The ratio in which isotopes occur in nature. The ratio in which isotopes occur in nature. That is known as the percentage abundance, boys and girls. So for chlorine 35, this isotope has an abundance of 75%. And this isotope has an abundance of 25%. So boys and girls, everybody, 75% means that if you take 100 atoms of chlorine, then out of 100, 75 atoms would be the ones which are having mass of 35. And 25 atoms would be the one which would be having mass of 37. Okay. So this is the meaning of percentage abundance. It simply tells you the ratio in which they are found. So once again I will repeat, issued in public interest, everybody pay attention. If you take 100 atoms of chlorine, out of those 100 atoms, 75 atoms would have a mass of how much? 35. And 25 atoms would have a mass of 37. Okay, 25 atoms would have a mass of 37. Okay, everyone. So now we have to find out the average atomic mass. Okay, Average atomic mass. So beta, what is the meaning of average? Average का meaning होता है, average means total upon number of things. Total upon number of things. Average means total. Sir, how can we say? Beta, that is experimental. That is what I am telling you, Janvi. It will be given to you in the problem. That is experimental data. When experiments were conducted, then we found this ratio. Okay, everyone? So this is derived experimentally, beta. Okay. So now, if I have to find the average atomic mass, see, average means the total divided by number of things. So suppose I have taken 100 atoms of chlorine. 100 atoms of chlorine. So in 100 atoms of chlorine, 75 are those whose mass is 35. So 75 are those whose mass is 35. So what will be their total mass? 75 into 35. 75 into 35 plus 25 atoms are those whose mass is 37. So what will be their total mass, everybody? Tell me quickly. It will be 25 into 37. This is the total mass of 75 atoms and this is the total mass of 25 atoms. Is this okay or not, everyone? Okay? If you take 100 atoms, 75 have a mass of 35 and 25 have a mass of 37. This is the total mass, everybody. Divided by the total number of atoms. So total number of atoms is how much? 75 plus 25. Now you solve this. Okay. Now you solve this. So how much will you get? Tell me, everybody. 75 into 35 is how much? 75 into 35 is how much? Solve this value and solve this value. Tell me the values. Denominator I have solved for you. See, 50% of the calculation I have done. I have solved the denominator, that is 100. Only numerator you need to solve. Half of the calculation I have done. 50% I have already done. Okay. Other 50% I am expecting you to do. So 75 into 35 is 2625. I think if you solve this complete numerator, it would come out to be 3550. Everyone is getting 3550. And divided by 100. 3550 divided by 100. Right? So 3550 divided by 100 is equals to 35.5. Understood, everybody? Bachcho, 35.5 it is it clear, everybody? Okay, very good. Congratulations. So if I want to give a general formula for average atomic mass, so general formula for average atomic mass would be N1A1 plus N2A2 plus ... Bhai, in this example there were two isotopes. It can be possible that there can be three isotopes also. Okay, N1A1 plus N2A2 plus ... upon N1 plus N2 plus ... N1 plus N2 percentage will be 100 only. Okay, N1 plus N2 plus ... will be equals to 100% if percentage abundance is given. Okay, there can be three isotopes also. One is having 80%, other is having 10%, other is having 10%. That is also very much possible. My dear kids, Is this okay, everyone? All of you? Quickly note it down. I'll give you one more problem. What is N? N is the percentage abundance, beta. Percentage abundance of isotope 1. देखो इधर है ना, N1A1 plus N2A2 upon N1 plus N2. If 3 isotopes are there, N1A1 plus N2A2 plus N3A3 upon N1 plus N2 plus N3. N is the percentage abundance over here. Is this okay, everybody? Have you all understood this? Yes, everybody, quickly give me a thumbs up. You have noted it down. Chalo, very good. Congratulations. Okay, very good, very good. Next question is that magnesium has two isotopes. Magnesium has two isotopes, Mg24 and Mg26. Mg has two isotopes, Mg24 and Mg26. Average atomic mass is 24.25. Find percent abundance of each isotope. Find percentage abundance of each isotope. Chalo bhai, quickly solve it for me. Everybody. Quickly solve it. Everyone, come on, go for it. Percentage abundance of each isotope. Come on, boys and girls. Who gives the first answer? Narayani Shrestha, 87.5 for which isotope? 24 or 26? Abhishek Vanapalli, 13.5 or 12.5, beta? Please understand the question. You have to find the abundance over here. Yes, Abhishek, very good. Very good, very good. Well done, boys and girls. So what will we do over here? Let's try to discuss this, everybody. Yes, most of you have given correct answers. Well done. Very good, everybody. So we have two isotopes over here, everyone. Let's have a look, everybody. We have Mg, which is 24, and we have Mg, which is 26. These are the two isotopes, Mg24 and Mg26. We have to talk about their abundances. So let us say this has an abundance of, let's say this has an abundance of X%. See, there are only Rundu isotopes. So if one of them has abundance X%, then what will be the abundance of the other one? Tell me fast. if one has abundance of X%, then what would be the abundance of the other one? 100 minus X, because total is 100 only, na beta? Total how much? Total how much? 100. So if one has abundance X%, the other one will have 100 minus X%. And now use the formula N1A1 plus N2A2 upon N1 plus N2. So N1A1 is 24X. N2A2 is 26 into 100 minus X. Upon N1A1, 24 into X, N2A2, 26 into 100 minus X. Is this okay, everybody? Divided by, I'll write it again, sorry. So 24X plus 26 into 100 minus X upon N1 plus N2. X plus 100 minus X is how much? 100. And this is equals to 87.5. Sorry. This is equals to 24.25. 24.25, that is the average atomic mass. Average atomic mass has been given to me as 24.25. Is this equation clear, everybody? Is this equation clear to all the kids? Everyone? Tell me. Are you able to understand this? Everybody? Okay, now you need to solve this equation. So let's solve it. So we have 24x plus 2600 minus 26x is equals to 2425, cross multiplied by 100. 24x plus 2600 minus 26x is equals to 2425. Now 2425 comes this side and 2x goes that side. So you have 2600 minus 2425 is equals to, this is how much? Minus 2x. So going that side, it will become plus 2x. From here I get 2x. 2x is equals to 175. 2600 minus 2425. So 2x is equals to 175. X is equals to, everyone, 175 divided by 2. That is equals to 2 8s are 16. 2 8s are 16 and 187.5%. So what is the moral of the story? Moral of the story is Mg24 percentage is 87.5 and Mg26 percentage how much? Mg26 percentage how much, everybody? Tell me fast. 100 minus 87.5. So 100 minus 87.5 will be equals to 12.5%. This is your answer. Have you all understood this? Everybody? 87.5 and 12.5. Is this clear, everyone? Okay, very good. Very, very good. And truly, whenever we say atomic mass, whenever we talk about atomic mass, truly, atomic mass is always the average atomic mass, always. So atomic mass is always the average atomic mass for any element. What do I mean by this? Okay, what do I mean by this? By this I mean that for any element, when you have to talk about its atomic mass, sir, I have a doubt, is atomic mass and atomic weight same? That is a very good question you have asked, Priya. Okay. See, normally mass and weight are different. Like for example, if your mass is 60 kg, like in your everyday life, let me answer, Priya. Everybody, please pay attention. So suppose if I ask you, what is your weight? You will say, sir, 60 kg or 70 kg, whatever, 50 kg. But 50 kg, 60 kg, 70 kg is not your weight. It's your mass. 50 kg, 60 kg, 70 kg is your mass. It's not your weight. Weight is m into g, that is acceleration due to gravity. Understood? That is the force. So suppose if g is 10 meters per second square and your weight is, your mass is 70 kg, then your weight would be equals to 700 newtons. That is the ideal meaning of mass and weight. Perfect as per physics. But normally in our everyday lives also, okay, yes. In our everyday lives also, we consider mass and weight to be almost same. We use them in the same sense, na? In chemistry, mass and weight mean the same. In chemistry, mass and weight, we treat them to be the same. So that is what is the answer to your question. So yes, in chemistry, atomic mass and atomic weight are taken as the same thing. That is the mass of, okay, one atom. So mass and weight are taken as basically the same thing in chemistry, but ideally they are not same. But in general, everyday life language also we consider mass and weight to be the same. So from that point of view, you can consider them to be same. So now, whenever we talk about atomic mass, boys and girls, atomic mass strictly means the average atomic mass. For any element, atomic mass should be the average atomic mass only. Okay. So like, for example, pay attention now, very important point coming. For hydrogen, for so many days, you have been using the atomic mass 11111. But if you actually go and check in any data, actually check the book or NCRT maybe, then you will find hydrogen is equals to 1.008. 1.008. So what is the story behind this 1.008? See, H1, H2, H3. This is called protium. This is called deuterium. And boys and girls, this is called tritium. This is called tritium. Protium, deuterium and tritium. Understood everybody? Protium, deuterium and tritium. So now, ideally we should be taking the average of all three of them as per their percentage abundance. But you will say, sir, for most of the times, I take hydrogen as 1 only. Yes. For the elements for which you have taken 1 and for carbon you have taken 12. For nitrogen you have taken 14. Okay. So what happens is that the isotope, which is the most common isotope, has a very high abundance. जैसे क्या है कि for hydrogen, this isotope is almost 99%, almost 99%. So if this is 99% abundance, okay, so what does that mean? Acha, sorry, I have written the spelling wrong. Tritium, sorry, very sorry. Tritium. Yes, sorry. Okay. I wrote the wrong spelling. Anyways, so what I'm trying to say, please focus on that. So I'm saying is that for hydrogen beta, this isotope with 1 has almost 99% abundance. So means these two have negligible abundance. So if they have negligible abundance, then 99% of the hydrogen is in this form, then the average will come almost 1 only, na? By, for example, suppose you gave a test for 10 different papers. Out of 10 papers, in 9 papers, you got 90, 90, 90, 90, 90. and in one paper you got 80. So your average will be closer towards 90 because you have scored 90 more number of times. Are you able to understand this, everyone? This is a very crucial point. So this isotope has 99% abundance. So that is why we take it almost hydrogen approximately. Meaning of this, what is the meaning of this sign? Equal to. What is the meaning of this sign? Sorry, what? 1 minute. Meaning of this sign, everybody, is equal to. And what is the meaning of this sign? This is approximately equal to. Okay, approximately equal to. Yes. So because 99% hydrogen is in the form of 1, so that is why we approximately take it as 1. But in case of chlorine, in case of chlorine, beta, what happened? In case of chlorine, both the isotopes, in case of chlorine, both the isotopes had good enough abundance. You can't say that one is negligible. Here both have good enough value, na? So you need to show respect to both of them. You can't say ki bhai nahi, you are 25%. 25% is good enough. 25% is 1/4. 1/4 of chlorine is in this manner. So now over here taking the average becomes very, very important. Sir, do isotopes of same element have same mass? नहीं यार, कैसी बात कर रहे हो जानवी? Isotopes have different mass ना. This is the definition of isotopes. Isotopes have different mass. So have you got the logic or not? कि why did I say hydrogen is 1 in the first class? Why did I say hydrogen is first in the last class? Have you got the logic? No, there is no element. Every element has isotopes. Every element has isotopes. Every element has isotopes. And ideally, whenever we talk, the abundance may be less or more. The abundance may be less or more. But every element has isotopes. And whenever we talk about atomic mass, whenever. So if you go to the actual periodic table in NCERT, and there you will find for every element, some fractional value is given, 1.008, 12 point something. But if it is 1.008, then calling it as almost 1 is not a crime. But 35.5 cannot be called as 35. That is a crime. I hope you understand what I am trying to convey, boys and girls. So atomic mass is always the average atomic mass. Whenever we talk about atomic mass, we should consider all the isotopes in their relative abundance ratios. And abundance ratio is something which is experimental in nature, which we cannot predict on paper. Is this understood, everybody? Every element I am saying has isotopes. The AU is an element. Na? You don't have to memorize what are the isotopes. You don't have to memorize this data. You just pick up NCERT and go and check. So sodium atomic mass, Google it. Sodium atomic mass, you remember 23. But if you Google it, you will not get exact 23. Okay? So I'll just do that for you. 23 point something will come. Exact atomic mass of sodium. So any element has isotopes. Understood now? I hope you have got it. Okay, boys and girls. So that was about average atomic mass. Everybody? Everybody has isotopes in this world. Everyone. Okay. If it does not have isotopes, then also we do not bother. Na? We can't memorize isotopes of everything. That is not what is expected from me. If you ask me what is the atomic mass of hydrogen, I will give the answer as 1 only. But ideally, atomic mass is always the average. Remember that. Okay? Good. So next, after studying about this, next which we will begin with is maybe we can do a few more questions based upon this. Okay. So just have a look at some more problems. Just a minute, okay? One minute. Okay, solve this problem. Abundance of isotopes of 54 Fe, 56 Fe and 57 Fe are (54 Fe, 56 Fe, 57 Fe) are 5%, 90% and 5% respectively. Find the atomic mass, and see, atomic mass means average atomic mass always. Find the atomic mass of iron. Okay, everybody try to do it. Solve it, everyone, quickly. Tell me the exact answer. Abhishek Vanapalli has got. Kirti has got. Janvi Reddy has got. Vishnu, check your calculation. Yes, yes, well done, boys and girls. Very good, excellent. Keep it up. When will stoichiometry get started? But just after this, Gautam. Hopefully little bit we'll do in today's class. We will continue with it in the next class. So what are we going to do over here, everyone? Tell me the answer. ठीक है भाई, very good boys. वैसे just for your, don't think that I am trying to boost your confidence falsely. This question was asked in JEE 2009. JEE, I'm not talking about NEET. JEE, IIT JEE. For 3 marks out of total 116 chemistry. This is a JEE 2009 question. Options are also given, but I have not given you the options. Don't think that I am falsely boosting your confidence. This is actual. You can search it online also. Just type the 2-3 lines of the question. The same will appear. You can search that in Google. So average atomic mass is 5 into 54 plus 90 into 56 plus 5 into 57, 5 into 57, 5 into 57 divided by total 100. 5 plus 90 plus 5. So now just perform this calculation. 5 into 54 is how much? 5 4s are 22, 270. 90 into 56, 9 6 are 54, carry over 5, 9 5s are 45 and 50, 5040. And 5 into 57, 5 7s are 35, 3 and 285. Whole divided by 100. Whole divided by 100. So how much is this, boys and girls? 005. Acha, then I have 7 plus 4, 11, 11 and 8, 19. Carry over 1. 1 and 2, 3. 3 and 0 and 2. 5 and 5 divided by 100. So 55.95, everyone is getting that? 55.95, that's the correct answer, yes. 55.95, that is the atomic mass. And whenever we have to talk about atomic mass, we have to talk about average atomic mass only. Atomic mass always means average. If one isotope has very high abundance, then we take it as the mass of that isotope only. But otherwise, in general, we must consider the contributions from each of the isotopes. Is this okay, boys and girls? Quickly note it down. Let's move forward. Let's move forward. I hope everyone is ready. Isn't it? Everyone ready? Okay. So next after this, we will begin with the super duper ultra pro max important topic called stoichiometry. Stoichiometry. Little bit introduction today. More details will follow in the next class. Today just little bit introduction. Okay? Stoichiometry. So what is stoichiometry? Stoichiometry talks about analysis of a balanced chemical equation. Analysis of a balanced chemical equation. Okay. This is what we need to do in stoichiometry. Now, once again, as you know, whenever I start a new topic, I start it from zero level, basic, fundamental. And initially, I go very slow. Because personally, I believe that is your concept formation stage. If the concepts get right into your head, after that, we will build upon that concept and do lots and lots of problems. That is my personal way of approach towards teaching. Okay. So very important concepts are coming. Please pay attention, everyone. Okay. Very important. So first of all, what is a chemical equation? What is a chemical equation? Pay attention. Chemical equation is a shorthand scientific representation. Matlab, how to represent a reaction on paper. So that is known as a chemical equation. Suppose if I write an equation, H2 plus O2 goes to H2O. So this reaction is telling me that hydrogen and oxygen are chemically reacting with each other to form water. So this is known as a chemical equation. Chemical equation, what is equation? It is a shorthand scientific way to represent a reaction on paper. For me on board, for you on paper. Okay. So this is a chemical equation, right? Now, right now, this equation is a unbalanced equation. An unbalanced equation does not give us too much information. It only gives us qualitative information. Ki bhai, this is telling me ki hydrogen and oxygen are reacting to form water. Using an unbalanced equation, I cannot do any calculations. Qualitative information, not quantitative information. So now we have to balance this equation. We have to balance this equation. Okay. We have to balance this equation. Now, if I want to balance it, a balanced equation should have same number of atoms, which means it should follow law of conservation of mass. Abhi after some time I will write it down. It should have same number of atoms of every element on both sides. This is the meaning of a balanced chemical equation. Okay? So here you have two hydrogen atoms. Here you have two hydrogen atoms. So hydrogen is balanced. Look at oxygen. Here you have two oxygen atoms. Here you have only one oxygen atom. So oxygen is not balanced. Oxygen is not balanced, 2 and 1. So I want to balance oxygen. So in order to balance oxygen, can I put 2 over here? Is this balancing? This is balanced now, no? नहीं इसमें क्या प्रॉब्लम है? This is balanced. I put 2 over here, no? Oxygen is balanced. No sir, no sir, no sir, no sir, no sir, no sir. हाँ, because in doing this, very good. You have changed the equation here. Earlier water was the product, and now you are saying hydrogen peroxide is the product. So balancing like this, not allowed. Very bad balancing like this is not allowed. This is not the way to balance. Then what do? We cannot change the reactants and products. This is important. So in order to balance it, 2 oxygen, I will put a 2 over here. I will put a 2 over here. Okay? Now once I have put 2, this hydrogen has become unbalanced. So hydrogen has become 2 into 2, 4. So here also what will I do? I will put a 2. So now hydrogen is balanced. So this reaction is known as a balanced chemical equation. And a balanced chemical equation, my dear students, is a chala useful thing. Very, very useful. Extremely super duper pro max important useful. So what does a balanced equation tell us? See, in a balanced equation, these numbers which are used for balancing, like over here you have 2, over here you have 2, and where nothing is written means 1. These numbers which are used for balancing are called, they have a very fancy name, okay, very glamorous, glamorous name. What is the name? Stoichiometry. Matlab fundamentally they are numbers only, but we glamorize them. Okay, by giving them some extra importance. So we glamorize them by calling them stoichiometric coefficients. Such a heavy name for something so very simple. Stoichiometric coefficients. Right? When you use such word, then the gravity of the topic increases. Right? Like all these particularly the Russian and the German scientists, and mostly the Europeans and all, they have such glamorous names. Have you heard that? Bohr's rule, Niels Bohr rule, Rutherford's experiment, Hund's rule of maximum multiplicity, Pauli's exclusion principle, Mulliken's oil drop experiment. अब suppose करो Mulliken oil drop experiment की place पे, मतलब suppose sometimes as when I was your age, so I used to wonder about this as a kid, that if Indians had made all these discoveries, then we would have not taken them seriously na, if it was being taught in class. जैसे Millikan's oil drop experiment के place पे suppose you are taught Mishra's oil drop experiment, Mishra's oil drop experiment, Gupta ji's rule of multiplicity. ठीक है? So everyone would feel that some joke is coming. Rutherford's alpha particle scattering experiment, Reddy's alpha particle scattering experiment. Reddy's alpha particle scattering experiment. Okay. Srivastava exclusion principle. So this would become. I personally would not take it very seriously. If my teacher comes in the class and announces this in the class, suppose I am a student and my teacher comes, today I'll teach you about Mishra's oil drop experiment. So personally, I would not take it very seriously. I would say that some joke is going to come or what. But as soon as you say Millikan's oil drop experiment, then some gravity, it carries that gravity. So that is why we have given the word stoichiometric coefficients over here. So that it's fundamentally a very simple thing, but it adds a lot more gravity to this concept. Okay. So anyways, so this is a balanced chemical equation. Balanced chemical equation follows the law of conservation of mass. Balanced chemical equation follows the law of conservation of mass. Follows the law of conservation of mass. Stoichiometry does not mean balancing. Balancing means balancing. Stoichiometry means analysis of balanced chemical equation. Stoichiometry does not mean balancing, Munna. Balancing means balancing. Stoichiometry means analysis of balanced chemical equation. So balanced chemical equation, this is my short way of writing equation. EQ'(N). Whenever I write this, it means equation. So balanced chemical equation follows the law of conservation of mass. Yes. Now, in this whole topic of stoichiometry, I will rewrite this equation again. Okay. What is the equation? Rundu H2 plus Okati O2 goes to Rundu water. In this whole topic of stoichiometry, the basic fundamental idea is that what do these stoichiometric coefficients represent? What are they telling us? What information are they giving us about the reaction? This is the theme of this topic. What is it telling me? What are they that every balanced equation is saying something to me? Now it is up to me whether I am able to listen it or not. This is what stoichiometry is. Every balanced equation is saying something in our ears. It's whispering something in our ears. Whether we are able to understand it or not, that is the idea behind stoichiometry. So what is stoichiometry all about? So beta, in a balanced chemical equation, what is this 2H2 and 1O2 telling you? It is telling you that for every one molecule of O2 consumed, 2 molecules of H2 will be consumed. For every one molecule of O2 consumed, 2 molecules of H2 will be consumed. But in chemistry, we do not do the counting like this. Suppose if I multiply it by 12, this will also get multiplied by 12. So this will become 1 dozen molecule, and this will become 2 dozen molecule. By every 1 molecule of oxygen will react with 2 molecules of hydrogen. So if I have 12 molecules of oxygen, they will react with 24. 12 is how much? 1 dozen. 24 is how much? 2 dozen. But in chemistry, counting is not done in terms of dozen. In chemistry, counting is done in terms of mole. Yes, so just like you multiplied it by 12, it became dozen. If you multiply it by Na, it will become mole. So 1 mole O2 will react with 2 moles of H2. 1 mole of O2 will react with 2 moles of H2 to form 2 moles of water. So in a balanced chemical equation, the stoichiometric coefficient tell us the mole ratio. They tell us the mole ratio in which the reactants would be consumed and products would be formed. Write down this line in your copy. Write down this line in your copy. NOTE VVIP. VVIP is very, very important. In a balanced chemical equation, the stoichiometric coefficients represent what do they represent? They represent the mole ratio in which reactants are consumed and products are formed. In which reactants are consumed and products are formed. What is the difference between stoichiometry and mole? Beta, mole is a counting unit. Stoichiometric coefficient is a balancing number. Mole can be present anywhere. Stoichiometry will only come in an equation. Okay? So, in a balanced chemical equation, the stoichiometric coefficients represent the mole ratio in which reactants are consumed and products are formed. Note it down first of all, and after you have written it, give me a thumbs up. This is the ratio in which reactants will be consumed. And this is the ratio in which products would be formed. And which ratio is this? This is the mole ratio. Very important. So now, what is this equation trying to tell me? This equation is telling me that suppose some container is there and in the container hydrogen and oxygen are present. 1 minute. Hydrogen and oxygen are present and they are reacting. So this equation is telling me that for every 1 mole of O2 consumed, 2 moles of hydrogen would be consumed, and 2 moles of water would be formed. When hydrogen and oxygen react, so every 1 mole of O2 that is consumed, 2 moles of hydrogen consumed, and 2 moles of water formed. So now, suppose I tell you oxygen and hydrogen are reacting in a container to form water. If 10 moles of oxygen is consumed, then how much hydrogen would be consumed? If 10 moles of oxygen is consumed, how much hydrogen would be consumed? How many moles? 20 moles. If I tell you 1000 moles of oxygen is consumed, how many moles of hydrogen would be consumed? If 1000 oxygen consumed, how much hydrogen consumed? 2000 moles. Okay. If I tell you 30 moles of hydrogen consumed, hydrogen oxygen reacting in water, 30 moles hydrogen consumed, how much oxygen consumed? 30 moles hydrogen consumed. How many moles oxygen consumed? 15 moles. Yes, very good. 100 moles hydrogen consumed. How much oxygen consumed? 100 moles hydrogen consumed, how much oxygen consumed? 50 moles. 100 moles hydrogen consumed, how much water formed? 100 moles hydrogen consumed, how much water formed? 100 moles hydrogen consumed, how much water formed? 100 na, are hydrogen and water ratio okati is to okati na. 2 mole hydrogen consumed, 2 mole water formed. So 100 consumed, 100 formed. 500 moles water formed. So how much hydrogen consumed? 500 moles water formed. So how much hydrogen consumed? 500 mole. And how much oxygen consumed? How much oxygen consumed? 500 moles water formed. 500 moles hydrogen consumed. How much oxygen consumed? 250 moles. Hydrogen is 500, oxygen is 250. So each of these questions which you have answered in the last 5 minutes, each of them is a problem of stoichiometry. So stoichiometry is very, very similar to the class 7th or maybe 8th problem of mathematics in the chapter called ratio and proportion. Ram and Shyam have their ages in 2:3 ratio. These kind of questions you have done in ratio proportion chapter. Ram and Shyam have their ages in 2:3 ratio. Ram is 10 years old. How old is Shyam? Ram and Shyam have their ages in 2:3 ratio. Ram is 2 years old. Yes, Gautam, you can write that also. How old is Shyam? So this kind of question is nothing but stoichiometry, where information about any one of the reactant or product is given. Information about any one of the reactant or product is given and the other is asked. So it is just a question of ratio proportion. Ki this much hydrogen consumed, so how much water formed? This much water formed, how much oxygen consumed? That's it. That's all that you need to do in stoichiometry. It is just a problem of ratio and proportion. So how is it a problem of ratio and proportion? We will see more examples of that in the coming class. Is this understood, boys and girls? So do we need to represent? Not always necessary. If you do that, Janvi, it's better, but not always necessary. But if you do that, it's good. In thermodynamics, we need to do that. In mole concept, it's not necessary. ठीक है. Thank you, everybody. Boys and girls, yes, Lochan, what is your doubt? Lochan has some doubt. Let him ask it. Another example in next class, beta. ठीक है, tomorrow. Repu class, another example. Lochan bhai, sir, can we interchange N1 and N2 where? No, that you cannot interchange. Why will you interchange that? Dinesh, I have got the paper. I forgot it. Tomorrow class will discuss. I got the paper. Tell me the question number tomorrow. We'll discuss it. Okay? Before starting the class. No, Lochan. We should not do that. Why would we do that? Why would we interchange N1 and N2? Whatever is given for A1, we will multiply it with that. By every isotope has its abundance. So you need to multiply by the abundance of that isotope. ठीक है भाई, okay everyone? चलो, bye. Take care. Have a good day. I'll see you in the next class. Bye, champs. Good day. Bye. Love you all. Take care. Bye, everybody. Bye.